Today, we will be talking about biconditional statements and also section 2.4 in your book. A biconditional statement is a conjunction of a conditional and its converse. Remember that a conditional statement is if P, then Q. So let's look at an example. Say P is Amy is elected by the district coaches, and Q is Amy makes the all-star team. If P then Q would be if Amy is elected by the district coaches, then Amy will make the all-star team. The converse of that, if Q then P, would be if Amy made this all-star team, then she was elected by the district coaches. The conjunction of that, the biconditional, would be if Amy is elected by the district coaches, then she makes the all-star team, and if Amy made the all-star team, then she was elected by the district coaches. This is a very long statement where P and Q are repeated twice. So in order to make biconditionals more efficient and easier to write, instead of using the word and writing the converse and its conditional in the entire statement, instead we will take P and Q and write the words if and only if in between them. So we can take this statement up here and condense it to say, Amy makes the all-star team, P, if and only if she is elected by the district coaches, Q. This statement means this statement up here. Since in a conjunction, both statements have to be true in order for the whole statement to be true, the converse and the conditional itself must both be true in order for a biconditional to be true. The symbol for a biconditional shows the arrows going both ways to show us that the biconditional means if P then Q and if Q then P, shown here. You will also see if and only if abbreviated as IFF. I want to remind you about the two kinds of reasoning that we talked about before. Inductive reasoning, where we use patterns or examples to help us to make a conjecture. We see something happening and we assume that that will continue to happen and make a conjecture based on that. That's inductive reasoning. Deductive reasoning, we use facts and explanations to say why something is true. We're going to be talking today about two tools of deductive reasoning. First one is called the law of detachment. The law of detachment states that if a conditional is true and P is true, then Q must also be true. This takes what we already know about if-then statements. We know that if-then statements are true if the hypothesis is true and the conclusion is true. This is saying the opposite, that if the conditional is true and P is true, then Q must also be true. This part must happen first, and then we can say that this will happen according to the law of detachment. So here are our symbols here. If the conditional is true, and I have an example of the hypothesis, then the conclusion must always come true. We use the law of detachment to say whether a conclusion is valid or invalid based on the information we are given. The only way we can use the law of detachment to say a statement is valid is if this first part happens. We have a if-then statement that we know is true, and we have an example of the hypothesis happening. If that occurs, the reasoning is valid and we can make the conclusion Q. The second tool that we're going to use for deductive reasoning is called the law of syllogism. The law of syllogism is like a chain. I have a chain of if-then statements, kind of like dominoes. Notice what we have here. I have an if-then statement, P, if P, then Q. The next statement must start with the conclusion of the first statement, if Q, then R. If both of those are true, then I can conclude that if P happens, R will happen, or if P, then R. So this statement shows us if P, then Q, and if Q, then R, then if P, then R. Again, in order for us to use the law of syllogism to say our reasoning is valid and to make a conclusion, this must happen exactly that way. I have a statement, if P, then Q. I start the next statement, if Q, then R. Then I can make this conclusion. If this does not happen, then I have to say that the reasoning is invalid and I cannot make a conclusion.